At this point in the course, we have learned how we can use Newton's second law of motion to understand why objects move as they do. In short, it is forces or interactions between objects which allow the objects to change their speed or their direction of motion. In this module, we're going to see how Newton's second law of motion can lead us to a very different understanding of motion. And this new understanding of motion is going to be based on two new concepts, which we will call impulse and momentum. We're going to begin in this video by seeing how Newton's second law of motion leads us to the concept of impulse. To get started, you can see that I have this bottle sitting here. Let's suppose that we know the mass of the bottle, and then I'm going to come in with my hand and exert a force of known strength on the bottle. So if we know the mass of the bottle, and we know the strength of the force that I'm going to exert on the bottle, do we then know what the velocity of the bottle will be when my hand stops pushing on it? So let's see. Let's say that first I give the bottle a little push like so. Now I'm going to do that for a second time. And in the second time, I'm going to apply an equally strong force to the bottle. What was different about those two trials? The mass of the bottle was the same between those two trials. The strength of the push was the same between those two trials. What was different between those two trials was the amount of time for which my hand was pushing on the bottle. When my hand pushes on the bottle for a short time, that was the result. When my hand pushes on the bottle for a long time, we get a different result. So it's not enough to know the mass of the bottle and the strength of the force that my hand exerts. We also have to know the time interval for which the force is acting. To start putting all of this together, let's consider a situation where a force F acts on a mass m for a time delta t. We're going to try and figure out how that force acting for that amount of time affects the motion of the mass. To get started, let's say that I have here a mass m moving along with an initial velocity v initial. Now what's going to happen is that some force F comes in and starts acting on the mass. That force will continue acting on the mass through a time interval delta t. And when the force is done acting on the mass will have a new velocity, which we're going to call v final. How do the mass, the force, and the time interval for which the force acts all come together to determine the change in the motion of the mass? As a first step, let's start by writing down Newton's second law of motion. If we only have this one force acting on the mass, then that force is equal to the mass times the acceleration of the mass. Now remember that acceleration can be written as change in velocity over change in time. Now let's take that delta t in the denominator there and move it up to the numerator on the left side. And that gives us force times time interval equals the mass times the change in velocity. You can see that we have now related the change in velocity to the force, to the time interval for which the force acts, and the mass. This quantity appearing on the left side of the equation is known as the impulse. The impulse actually gets its own symbol, which is capital J. The impulse, capital J, is a vector quantity, thus I have that little arrow symbol there. And we're going to define that as the force that's acting on the mass multiplied by the time for which the force acts. Now, going back to the previous equation, we're going to replace that expression F delta T on the left side of the equation with this new symbol J vector. So we now have J vector, the impulse acting on the mass, is equal to the mass times the change in the velocity of the mass. In the next video, we're going to do a straightforward example using this result.